Hey guys, I just thought I'd quickly go through the mock with for you, seeing as we don't really have a lot of time in lesson time. So you can pause this video whenever you need to and take it at your own pace, really. So the first question is about investigating biodiversity of a moorland. Question 1A says, describe the method that students would have used to investigate the abundance of plant species, how many plant species there are in the moorland. Okay, so that is all. This method is all about using the grid method for placing the quadrats. So the first mark is in fact stating somewhere that you've used quadrats and that you set up a grid. In order to put your quadrats down, you need to reduce bias, so you do that by randomly generating coordinates. It's important you state the word randomly. Okay, so you randomly generate coordinates to place the quadrat down. Once you place the quadrat, you would count the number of species, the number of plants of each species. Okay, and be careful, it is plants. Quadrats are only used to count plants because plants can't move. If you say animals, that's not quite correct. Next question, B part 1, calculate the percentage change in narrow-leaved grass between 2014 and 2016. So narrow-leaved grass is here on the graph. 2014 is there, which is 15, and then 2016 it is up. Let me just zoom in. Up here, which is about 37. Okay, so percentage change, we need to know what the change was. 37, take away 15, which is 22. And then you divide that by the original, which is 15. And to make it a percentage, you times it by 100. So all in all, what you should get to is 146.66666 all the way through to 7. So you can simply round it as that. State 2 pieces of evidence that show that the biodiversity of the moorland increased between 2014 and 2016. If you look at the graph, you should be able to see that the number of heather has increased, the number of narrow-leaved, broad-spectrum grass, sphagnum moss, all the number of individuals has increased. Okay, so first mark, the number of each species has increased, or the number of individuals within each species has increased. Okay, also there was no heath bed straw before in 2014 or 2015, nor was there any torm until in 2014, so the number of species itself has increased. Okay, so if you remember the definition of biodiversity, it's the number of each species and the number of individuals within each species. So that's where you get that answer from. Suggest why the students sampled several areas over the moorland. Okay, so quite a few answers. The easiest one is to increase the confidence in the results. You could also say to ensure the results were representative of the whole area. You could also say to increase the validity of their conclusion. Part 2, suggest how over the 3 years the students made sure the investigation was a fair test. You carry it out at the same time of year. You would also need to use the same sample sites or the same sample area each year. So carry it out at the same time of the year, carry it out at the same place. Okay, so question, it should be question 2, but it's question 1. It's all about biological control. And you are asked to give 2 advantages of biological control. There are a lot of advantages. I'll name 2 here. So first of all, most people put no pollution, damage to the environment, poisoning, no use of pesticides is the one that most people said. For this same marking point, you could have said no pollution, no damage to the environment, no poisoning, no use of chemicals, no use of pesticides, no bioaccumulation. Another advantage you could put down is that biological control is specific, or it only targets pests, or it does not kill other organisms or other insects or non-target organisms. Another advantage is there is no resistance that could occur to the biological control. It only needs to be introduced once. And or you could say it's a long-term method, and once set up, it's a low cost. You don't need to keep paying money like you do with using pesticides. So 2 disadvantages. It costs a lot of money to research biological control to see if there is going to be an effect. Not all the pests are going to be eradicated. It could become a pest itself. Or you could also say it could disrupt the food chain or outcompete other species. It takes time to actually work, and it could introduce disease. Intro. I can't spell introducing. Introducing disease. Got there in the end. Okay, so any of those 5 for the disadvantages and any for the advantage, 1 mark for each, of course. The whitefly, you got given a lot of information there. You're also given a graph to go along with it. The use of E-Formosa to reduce the number of whiteflies is considered to be successful when there are 20 or fewer whiteflies per plant. Use graph 1.1 to determine how many days it took for the number of whiteflies to fall to 20 following the introduction of E-Formosa. The use of E-Formosa to reduce the number of whiteflies is considered to be successful when there are 20 or fewer. So at that point there, use the graph to determine how many days it took for the number of whiteflies to fall. Okay, so at day 38 by the looks, that's when it was considered successful. And it was introduced. On day 7. You need to read the question. There we go. Okay, so on day 7, at this point here, it was introduced. So from there all the way to there is how long it took for it to work, for it to bring it back down below 20. So 38, take away 7, 31. You could accept 31.5 or 32 depending on how you read that point there. I could award 1 mark for just putting that number there, so I could accept I could give 1 mark for 38, 38.5 or 39. Suggest a reason why it took so long for the number to fall to 20. Okay, so after day 7 it did initially rise for a little bit before the numbers started to fall down. So the reason why is they needed to lay their eggs inside the whitefly, okay, and they need to lay their eggs, but then the eggs also need to hatch, and they need time to do that. So the clue here is why it took so long. It was all to do with the time the eggs needed to hatch. So the wasp eggs need time to hatch. Okay, it took time for the wasps to reproduce or start killing. It takes time to lay the eggs. It's all to do with the time needed. It suggests one reason why this method of pest control would not be effective to use if whiteflies damage wheat crops grown in Wales. Okay, it wouldn't be so effective because the optimal conditions are over 20 degrees Celsius. And I don't know if you noticed, it's rarely that warm for that long in Wales, so you could simply put low temperatures in Wales, or you could put low temperature. The temperature is less than 17 or 20 degrees Celsius. It or Wales, or the weather is too cold. E. formosa is not in a greenhouse, or it could fly away. Are any of the points I could accept? An alternative approach is to use pesticides. Why is it not appropriate? Well, E. formosa will die. The pesticide will kill E. formosa. Or you have to say the wasp. You can't just say it. Okay? And do not use the word harm, because harm means it's still alive. It kills or destroys the wasp.